Okie dokie. In this problem, we are given the definite integral from 3 to 8 of 3x cubed dx. Also, please excuse my voice. It's a little froggy and messed up. So, in previous problems, we had been evaluating indefinite integrals, which meant we had no boundaries from a to b. We had no a, no b. And so what we would do is just find the antiderivative and then add plus c. And in this case, we'll find the antiderivative, and then the process will look a little different. So we will still find the antiderivative of the inside first. So antiderivative, we add 1 to the exponent, and then we divide by whatever that new exponent is. And then, instead of adding plus c, we are going to evaluate this integral from 3 to 8. And so this is sort of the notation for that. It's like a little bar from 3 to 8. And so what this means is we're going to plug in 8, the upper bound, first. Then we'll plug in the lower bound, and then we'll find the difference between the two. So starting off, plugging in 8. Then we'll plug in 3. And then we will subtract them. So let's go ahead and just open Desmos and plug this in there. So we will have 3 times 8 to the 4th, all divided by, nope, that's not it, to the 4th, all divided by 4. That should work. And then minus 3 times 3 to the 4th, all divided by 4. And plugging all that in at once, we get 3011.2. So it looks like option B is our answer when we break out the eraser. So in these, in this like number, like type of problem, we don't have to use any serious integration methods yet. No U substitution. It's kind of just testing your abilities to find the antiderivative using that reverse power rule. So adding 1 to the exponent and then dividing by that new exponent and then evaluating it from a to b. So from 2 to 5, meaning we'll plug in 5 first, plug in 2 second, and then subtract them. So doing this again, 5 to the 5th divided by 5 minus 2 to the 5th, and then dividing by 5, I think it was, yeah. So that'll give us 618.6, I think. Yeah, all right. So we have that answer D right there. So, I mean, that took all of, hopefully, 20 seconds. And so these should hopefully be pretty quick. Again, they're just assessing your abilities to evaluate definite integrals. So on to trig stuff in the same type of problem. Find the antiderivatives of trig functions. You're going to want to know those. So I had thrown this little visual into another problem, but it's, buried deep within one of those problems. And so I'll write it out here again. There's a cyclic nature to the sine and cosine derivatives, which means there's a cyclic nature to their antiderivatives. Which means if we want to find the antiderivative of negative sine, then we go to negative sine and we follow the orange arrow, and it takes us to positive cosine. So the antiderivative of negative sine is positive cosine. We evaluate that from 2 to 4. So again, in the counterclockwise orange arrow direction, we will be finding the antiderivatives, or this tells us the antiderivatives. And then in the clockwise direction, it'll tell us the derivatives as we go around. So cosine of 4 minus cosine of 2, the evaluation of the upper bound minus the evaluation of the lower bound. So plugging this in, it looks like we get negative 0.2-ish. That looks like option B, but let's break out the eraser to confirm that it is, in fact, B. So again, with this, I might recommend taking a screenshot or picture of it. It might be helpful in other problems until you memorize it. All right. If you have any questions on these, please let me know.